Hello, I would like to tell you a bit more about this PhD project on 3D printing of edible biomimetic scaffolds for the engineering of animal muscle tissue. According to the latest projections, the demand for animal-based foods will increase by 70% in 2050. And yet, currently 800 million people worldwide suffer from hunger and malnutrition. The livestock industry is responsible for 12 to 18% of the total greenhouse gas emissions and is also the leading direct driver for deforestation. Increased meat production and factory farming are the top most likely causes of the next pandemic due to the extensive use of antibiotics. And last, but definitely not least, factory farming is associated with animal cruelty. So is there an alternative? Yes, absolutely. Here is a concept of cultivated or lab-grown meat, which is an alternative way to produce meat which is safer, more sustainable, and cruelty-free compared to traditional methods. How is it made? We start with a single biopsy from the animal, which, although it is an invasive process and inflicts some pain, of course, the animal is not yet killed. From this biopsy, we isolate the cells of interest, which in many cases will be adult stem cells. We then seed the cells and expand them in large bioreactors to create the cell mass, and since these cells are adherent, we will frequently use microcarriers. We then differentiate the cells on scaffolds to the two main cell types found in meat, which is muscle and fat cells. And finally, we process them into the final product. This project aims to combine edible polymers and 3D printing in order to create a scaffold material which will possess structural and mechanical properties that will support and maintain cellular viability and function. We will use edible cytocompatible polymers for the 3D printing process and investigate how various material parameters, such as, for example, viscosity and density, can influence the ink we're going to create and look to maintain its biocompatibility. Printing parameters such as, for example, speed, voltage, frequency will be optimized, first in the absence and then in the presence of the cells. We will also look how cell viability is affected during and post 3D printing, and also how we can protect the cells from potential stresses. Finally, we will explore ways to enhance the anisotropy of our scaffolds in order to encourage cell proliferation and maturation. And we're going to do that through a combination of 3D printing and conventional scaffold manufacturing techniques, such as electrospinning. So why apply for this project? First of all, you will receive full funding for 4 years. You will have the opportunity to work in a multidisciplinary team. We have a biochemical engineer, a mechanical engineer, and a cell biologist and immunologist. And you will also be fully supported by the members of Aston's advanced prototyping facility, who specializes in 3D printing. You will have guidance and input from our industrial collaborator, LGC Group. And you also have the opportunity to learn new techniques such as 3D printing, electrospinning, material characterization, and biological assays. But most importantly, your research will help to create a more sustainable future for our planet. And it is very relevant to quite a few of the UN Sustainable Development Goals. Thank you for listening.